Welcome to my class. In our session for today, we are going to discuss about the first principle. When it comes to the first principle, you can be told using the first principle, y is equals to sine x. You can be told to use the first principle in solving sine x. The first thing that you need to understand about the first principle is that a function f of x is equals to limit h approaching 0 This is our first principle formula, and this is the main thing that you need to understand. After knowing the first principle formula, the second thing that you need to understand is that a term of x will be replaced now with x plus h. And on this side, we are going to have a function f of x the way it is. So in our next step, we are going to have limit h approaching 0 will be equals to sine into x plus h. Since this is where we are having a term of x plus sine x, everything will now be all over the term of h. When you look at this one, we are going to apply the trigonometric rules so as to expand this one. And by trigonometric rules, we are going to say, but we understand that sine into bracket theta plus angle phi is equals to sine theta cos phi add to cos theta sine phi. So let us come here. We have sine into x, we add to h. So will be equals to, on this side where we have angle theta, we are going to replace with x, and where we have angle phi here, we are going to replace with h. So we are going to have sine x cos h add to cos x sine h. After having this one is the replacement of what we have here. Since we are going to expand this one using the trigonometric rules. So we are going to have limit h approaching 0 will be equal h approaching 0 sine x cos h, we add to cos x sine h. Add to sine x, and everything is all over the term of h. So here, when you check at sine x cos h, we can say it is a term of sine x to mean that they are both like terms. So we are going to connect the like terms together, and we are going to have limit h approaching 0 will be sine x cos h. We add to here's supposed to be a subtraction, and here we are going to have sine x we add to cos x sine h. Everything now will be all over the term of x. So after reaching this point, we can collect sine x as a common term on this one, and we are going to have limit h approaching 0 will be sine x into cos h minus 1. We add to cos x sine h, and everything now will be all over the term of h. So from here now we are going to distribute the limit in each and every term. And by distribution of the limit in each and every term, we are going to have limit h approaching 0. Here we will be having sine x. We multiply by limit h approaching 0. So the division is going to be all over h. Here we are going to have cos h minus 1, everything all over h. We add to limit h approaching 0 cos x all over h, and here we're going to have multiply by limit h approaching 0 multiplied by sine h, everything all over h. So what we've done here, is that we've only distributed the limits into each and every time by separation. So after doing this, after this step now, our last step we are going to say when we are in our last step, we are going to say that limit h approaching 0 cos x plus or minus 1 all over a term of h. This one is always equal to h. This one is equals to 1. And by use of these two, when we check on the numerator, we are going to have a function f of x will be equals to, we will say the limit sine x all over h will be equals to 1, and limit this one is equals to multiply by 0. We add 2, limits this one all over h is going to remain. So we're going to have limit h approaching 0 cos x all over h multiply by this one is going to be equals to 1. So here we are going to have 0, here we are going to have 1. Since we don't have a term of h on the numerator, we only have a term of h on the denominator, we are going to say that this one is going to cancel out and give us cos x as our answer. And this is now the differential. This is now the differential of a function sin x. And that is how you go about the differential of sines.